So today we are going to do a little switch of gears again. So we're going to stop doing dot and cross products now, and we're going to go back and just do vector addition basically, and with story problems. So I'm going to try to do three or four good examples for you for vector force story problems. So here's one little background. Tiny Tim, you know him from the Christmas Carol, right? Is dragging, of course, not his little sister, a sled with the Yule log on it. Home for Christmas, right? What are the components? Okay, so we've got our sled here, the rails, and we've got our Yule log on there, right? Our Yule log didn't have much of a log to it. Okay, and then Tiny Tim is pulling that log with a force of 12 newtons. Okay, and they just asked for, okay, what are the components, right? So he's pulling here. Here he is. There he is. And he's pulling that string and creating a vector of 12 newtons. Okay, so, and they have to tell us this angle here, or we can't do the components, right? So our angle theta is 30 degrees. We'll make it easy. All right, so for the components, you're just going to do what we've been doing before, horizontal and vertical. And so we're going to take that hypotenuse, right, of our triangle, and we're going to do 12 cosine theta. So cosine is going to give us that horizontal component, that adjacent side. And then 12 sine of 30. Okay. So this one, that one's root 3 over 2. So, but if we did that with a calculator, it would give us 10.392. And that would be our horizontal component. And our vertical component would be 1/2 times 12, which is 6. And we can write that as I plus 6j. And we're done. Okay, so that's a few of your problems will be like that. Just asking, okay, here's one force. Break it up into components. The second problem has to do with, it's going to have to do with that resultant vector. So it's going to have a couple of vectors. So here, instead of Tiny Tim, we're working with Jack and Jill. And you know what they did. They're fighting over the pail of water, of course. Are fighting over the pail of water. Okay. So part A, we just want to know, okay, what is the resultant vector? Okay, so say we've got our pail here. Here's our pail. And we've got, let's say Jill's over here. And she's pulling with 7 newtons. And Jack is over here. And he's pulling with 10 newtons. And then they also need to tell us, okay, what angles are these forces at, right? So here's the horizontal there, and this angle is 70 degrees. I didn't draw it very well. And this angle, say, is 60 degrees. Okay, so this is Jill. I'll put that J I, and this is Jack, J A. There. Okay, so again, you're going to split them up into horizontal and vertical components, and then you're going to add them together. So let's do Jack first. Okay, the problem with Jack is that he's going in that negative direction, right? So we need to find this angle from here all the way over is 180 minus 70, which is, yeah, you got it, 110. Okay, so we have 10, the magnitude, right, times cosine of 110. And then 10 times sine of 110. Okay, and then we're going to do Jill. And Jill is 7 cosine 60 and 7 sine 60. And we add those up. And we get 0.0797I plus 15.459J. So they are basically pulling it up the hill, right? And then they're pretty much equal. So the steps to do this, guys, I would say draw the picture first. Draw a pic, right? Steps. Split into components, so horizontal, vertical components of each vector, and then add them, and then add together. Okay, those are her steps. There we go. Okay, and then for part B, they might ask you for part B here, they're going to say, okay, what would be the third force to produce equilibrium? So a third force to equalize this force, right? Let's put a box around this because this is our answer. Okay, to produce equilibrium. So what does that mean? You remember? So it has to be equal in magnitude, but you got it, opposite in direction. So that's what we're thinking when we're thinking equilibrium. Equal in magnitude, opposite in direction. Okay, awesome. All right, so we need to find the magnitude. The magnitude, you guys remember how to do this. We're going to square this, add it together, and we get the square root. So we're going to use Pythagorean theorem, right, to find that magnitude of the sum of Jack and Jill here is equal to the square root of 0.0797 squared plus 15.459 squared. And we plug that into our calculator and we get something that's almost 15.459. It's 15.46, which we knew, right? It was going to be very close to that. And now we need to know the direction. So the direction, theta, is we know it's in the first quadrant because both of these are positive. So we get theta is equal to inverse tangent, the y over x. So 15.459 divided by 0.0797. This is going to be very close to 90 degrees, right? And it certainly is 89.7046 degrees. Okay, so opposite in direction, what does that mean? That means instead of going up here, like at 89 degrees, we're going to be going down here. How do we get opposite? We add, absolutely right, we add 180 degrees, right? So we plus 180 degrees. So if we add 180, you guys, oh, you can't see that, sorry. Okay, plus 180 degrees, and we get 269.705 degrees. Okay. All right, let's do one more. I think we have time. Let's do one more example. All right, we got Michael Phelps is swimming across the Columbia River. Since he can't go to the Olympics, right? So he's just going to be swimming. Michael is swimming across the Columbia. Oops, I can't spell across. Across the Columbia River. Okay, and the river is flowing south at 2 miles per hour. Okay, Michael, though, he can swim 5 miles per hour. So we want to know what angle should he swim to swim directly across. So what angle to swim directly across? The shortest distance, right? Okay, so here's our river. There's our Columbia River, right? And Michael's over here, Michael, and he's swimming across at 5 miles per hour. But the river is pushing him here at 2 miles per hour, right? But Michael wants to go directly across because he wants to save energy, right? Okay. So there we go. We want to know that theta, what angle. So we've got to do exactly what we always do. We're going to split it up into horizontal and vertical components, right? So for Michael, we'll put Michael here. Michael's got 5, right? And for horizontal is cosine. And we don't know our angle, so we're going to leave that as theta. The vertical component for Michael is 5 sine of theta. And then the water, or the river, the water is going south or down too. Does it have a horizontal component? No. So our horizontal component is 0, and our vertical component is down 2. So it's -2. Okay. And what we want this vertical component, if he's swimming directly across, we want that vertical component to be exactly. We want it to balance. We want it to be 0. So to balance, we want the vertical component to be 0. So let's write that down. Balance vertical component equals 0. Okay. All right, and so we'll just add these up. So 5 sine theta minus 2 has to equal 0. Right, so then we're going to solve. So we add the 2 over, and we have 5 sine theta, and we divide by 5. So we have sine theta is equal to 2/5. And then to solve for theta, that's right, you guys remember inverse. You're going to inverse sine 2/5. And when you do that, you're going to get an answer on your calculator, 23.578 degrees. All right, thanks so much.